Okay. Oh, okay, that's good. Okay, so it's time to start. So we'll have our first talk of the day. So our first presenters are KV Rajeesh and CV Radhakrishnan, and they will be talking on Malayalam content 2.
Hello, welcome to the TeX 2026 presentation about digitally archiving Malayalam text. This is a sequel to the talk delivered by CVR at TeX 2025 last year. Since then, we have considerably reworked the workflow to make it simpler and more efficient. I would like to provide an update to the workflow in this talk. The previous workflow was a bit contrived. It involved using Lua TeX to produce a special kind of PDF, which is not suitable for immediate user consumption because it only contains the hierarchically structured XML code. From this PDF, the text was extracted and transformed to produce an XML document, which involves quite a bit of manual steps as well as expertise. This workflow was developed more than 15 years ago, and then TeX was not capable of processing Unicode text for complex scripts. But in the last few years, thanks to the Lua TeX and ZTeX engines, as well as Mikhail Hoftik's works, TeX is now fully capable of supporting Unicode text as well as complex scripts like Malayalam. So we wanted to make use of the native capabilities and strengths of TeX to process LaTeX sources. In this workflow, the immediate output is in HTML, not XML. The difficulty in creating validated strict XML directly from LaTeX is multifold. First of all, TeX is quite macro heavy, and authors may use all kinds of complicated macros. And secondly, LaTeX output is a visual output suitable for printing or reading on screen. It does not generate a structured data. XML being structured data, creating such kind of output directly from LaTeX is quite complicated and at times error prone. Crucially, our volunteers who are also less skilled in XML technologies at times struggle with fixing the parse error in XML or its structure. So we wanted to separate the concerns of the lesser knowledgeable workforce, volunteer workforce at Sayana Foundation, to work with LaTeX sources. They can compile the sources, they can fix the compilation errors, and the immediate output is in HTML, which gives immediate visual feedback so that the volunteer can check the output, verify, and correct the sources if needed, and repeat the cycle. Once the HTML is verified, then the scarce limited number of expert volunteers can then work on the next part, which is to produce XML from this HTML. So the new workflow involves compiling LaTeX sources directly using TeX which produces a semantic HTML. This semantic HTML can then be converted to XHTML, which is similar to XML. From this XHTML, any kind of structured schema XML can be generated using XML processing tools such as XSLT or DOM or Saxon, etc. This helps us to separate the concerns of limited expertise versus complexity. HTML5 is quite suitable for our workflow, firstly because it provides immediate visual feedback. Secondly, LaTeX structures have equivalent mapping to XHTML, semantic HTML. For example, /section can be directly mapped to the section tag, or text IT, for instance, can be directly translated to the I tag, or a span tag with class italic, which can then use a CSS for rendering. Most importantly, TeX can generate MathML directly from LaTeX sources. TeX has been in our production use since many years. It's battle tested and it has excellent support for standard LaTeX packages and macros. In addition, the HTML output is also quite forgiving because if you miss to close a tag, it could still be rendered correctly by web browsers. But if you miss to close a tag in XML, it's a parser. It's very easy to convert semantic HTML into XHTML. Once we have the XHTML, then any standard XML toolchain should be able to produce a required XML schema. TeX works in 3 independent but coordinated steps. First step is to compile the LaTeX sources using TeX, which loads the texforest.style package that redefines most of the macros, and in its place, it injects special anchors to the DVI output. Once the compilation is over, these special anchors can be extracted from DVI and replace it with XML, HTML, or MathML tags. The final stage is run only if you need to extract graphics or if you need to split the output file by chapter, sections, etc. The real advantage of using TeX is that it uses a real TeX engine such as PDF TeX, TeX, or ZTeX. So it processes all the macros as if a PDF output is being generated. TeX can convert standard LaTeX commands to equivalent semantic HTML. Sometimes if you need to customize the output, the way to do it is to use the configure command. For example, let's convert the /section command in LaTeX to an equivalent semantic HTML section tag. Use the configure section command, which takes 4 arguments. The first 2, hcode section sec level 2 and hcode closing tag section, can be used to add specified code just before the start of the section block and after the entire section content is over. The last 2 arguments here in the example, hcode h2 and closing h2 tags, can be used to add XML or HTML tags before the section title and after the section title. Once TeX runs with this configuration, it will produce the equivalent output that you can see on the right hand side. MathML generation is straightforward with TeX. For example, if we have an inline math equation a plus b the whole square, simply compile it using make for st with the option mathml. It will produce mathml output as displayed below, including the math class for the operators and delimiters. The second challenge we had with digitizing Malayalam text at Sayana Foundation is we have volunteers with varying levels of expertise. The lesser skilled volunteers find it difficult to work with XML and fix its errors. Instead, they work with LaTeX sources, which they are quite familiar with, and they standardize the coding into strict predefined templates so that we use equivalent semantic environments, not just formatting commands such as vspace or textpf. And using TeX, the sources are compiled into HTML from which they can get immediate visual feedback and correct the sources if necessary. This process is repeated until the generated HTML is satisfactory and correct. Once that HTML is created, then the scarce expert volunteers can focus on the XML generation part and fix any errors. And this is where the domain experts like linguists also come into picture, where they can do named entity recognition, linking, critical apparatus, or XML schema validation, etc. This decouples the processing stage into varying levels of expertise and relieves the expert volunteers from the mundane tasks. We have also built an automated pipeline, which is basically a makefile that bundles 3 different steps. First step is to compile the input source file using TeX with the option mathml, HTML, and HTML5. This produces an HTML5 document, which needs to be converted into XHTML with proper opening and closing tags. For this purpose, we use the command line utility tidy. Once tidy runs through this input HTML, we get a strict XHTML, which can then be transformed into desired XML schema such as TEI XML or NLM or JATS by using XSLT Proc or Saxon or other tools. We have a case study of Kerala Paniniyam, which is an authoritative Malayalam grammar text published by Sayana Foundation a few years ago in PDF format. In the last year, we also worked to generate the HTML and XML format of it using the new workflow. We have also processed a number of articles, books, poetry, etc. using the new workflow, and those are available on the Sayana website. One particular stage of XML generation has to do with the domain expertise. For example, if we have an archival document which requires enriching with additional semantic information such as named entity recognition and linking, or critical apparatus, for example, the apparatus, lemma, and reading, this can be added during the HTML to XML conversion process. In addition, strict schema validation can also be automatically introduced, for example, using XML link. So we automate it as much as possible, but the meaningful part is still left with the experts and domain experts. Compare the old workflow with the new. Previous workflow has been using LuaTeX to create a specialized PDF, which is completely removed to use HTML produced by TeX. And in the previous workflow, all these steps require high level of skill, but now we have separated the first part of generating HTML from LaTeX sources can be run by much lesser skilled volunteers. The XML generation was also a manual process in the previous workflow, which is completely automated using XSLT processing in the new workflow. And the previous workflow did not support MathML, so we were unable to create XML and HTML of the 15th century mathematical treatise called Yukti Bhasha, which Sayana Foundation published a few years ago in PDF format. But with the new capabilities, we will be able to generate the XML and HTML version too. Since the previous workflow was complicated and contrived, only few people were able to work with it, but with the new workflow, a lot more volunteers can work with it. The major challenges implementing the new workflow was the initial configuration of TeX. An example was shown earlier, how to configure the section command, but it is much easier than writing LaTeX macros, for instance. And creating XSLT programs to ensure strict HTML generation was the initial challenge, and balancing this complexity of the configuration versus the lesser knowledgeable volunteers who work with LaTeX sources to strictly use specified templates was another challenge. What we learned is that a limited set of LaTeX commands in strict semantic environments using a LaTeX template greatly helped, and HTML5 is quite robust, forgiving, and human readable, close to XML format that could act as a bridge between LaTeX sources and XML. And lesser knowledgeable volunteers are familiar with LaTeX and they're familiar with LaTeX errors. They know how to fix those errors. So let them fail gracefully in that stage is much easier and productive than let them also fix the generated XML errors. This whole project is open source and it is driven by the community. Source code is available in GitLab under the organization Sayagna. Project name is archiving. All the code and documentation is licensed under LaTeX project license or equivalent free software license. The documentation is also included in the repository, which helps anybody interested to jumpstart. This workflow is language agnostic, so it could be extended for other Indian languages, Dravidian languages like Tamil, Telugu, Kannada, or other Indic languages like Hindi. With that, I would like to thank the organizers of the Tech Users Group Conference 2026, and I welcome any questions or discussions. Thank you very much.
We seem to have no signal on here.
That's fine. I just got to turn it back on.
Okay, we're on? Oh, thanks so much for that really interesting presentation. We have a few moments for questions if anybody has them. Yeah. Here we go. Yes.
Okay. Hi, I'm Marcel Krüger. It was a very interesting presentation. Thank you very much. One question I was wondering about, we now have a lot of the tagging support, which actually adds a lot of structured information to PDF files. Did you consider if it would now actually be possible to extract that directly as XML from the PDF and basically skip text for HT for these kind of use cases?
No, Marcel, we have not considered extracting XML tags or the accessibility tags from PDF and using that to generate XML. Maybe it's something that could be considered, but for us, TeX for HT works quite well.
Thank you.
Hi, this is Pavneet. I was curious that when you talked about segregating the workflow for lesser skilled and more expert users, did you design the workflow around the skill set of those two populations, or did you find people, assuming that there was a lesser skilled population of workers that you wanted to use, and you were trying to find those that fit the bill?
The Sayana Foundation is a volunteer-driven organization who is involved in archiving Malayalam content, and we have, as I mentioned in the presentation, a number of people who are not XML experts. Since it's a volunteer workforce, people come and people go. So we had to adapt our workflow based on the availability of the volunteer workforce. So yeah, it's the latter, that we design the workflow, redesign the new workflow so that it matches the skill set of the workforce. And we found it also quite beneficial for the expert workforce, who doesn't have to be bothered about the nitty-gritty details or the earlier part of the processing. They can focus on the important, such as fixing XML errors, or involve linguists or language experts who could work on enriching the XML part.
Okay.
Hi, Rajeesh. It's Carl. I just wondered how big the project is, how many lower skilled volunteers there are, how many expert volunteers there are, how many documents you've archived approximately? Just wondering.
Okay. The question to the first part, the number of workforce or the volunteers probably could be counted on a single hand, including both the non-expert and the expert volunteers. A couple of the expert volunteers, one of them is CVR, the other one is Ashok Kumar. And then we have a few people who work on LaTeX to HTML generation and pre-processing part. So far, we have, to my knowledge, which could be obsolete by now, we have processed more than 10,000 pages of text, including the old workflow and the new workflow. And we published a dictionary for Malayalam called Shabdataravali, which was a huge community effort. I think it was during the COVID period where a lot of people were able to find time to contribute this and the grammatical text. Plus, we also wanted to generate the XML format of Yukti Bhasha, which is a 16th century treatise on mathematics and astronomy, which discussed the fundamentals of calculus at least a century before Newton and Leibniz. We produced the PDF format, but was not able to produce the HTML and XML version because of missing math ML capability. So it's a future project. All these documents, there are a few English text as well, such as B.R. Ambedkar's discourses on caste in Indian context, plus a few short stories by Maupassant, in addition to the Malayalam content. It's all available on the sayana.org website.
Okay, well, thank you for answering those questions. And are we about ready to proceed on? Okay, thank you again.
Thank you very much.
Is this microphone on?
No.
Oh.
As usual.
So
If you just speak up, we can probably hear you in the room, and you don't need
Yeah,
yeah, it should be
it's,
working.
it's all right.
I think we should
I-
wait for 9:30.
Yeah.
Next talk.
Yeah, so as you see, the next talk's at 9:30. People may tune in